Thank you, Dr. Kramer, for that fascinating historical presentation this afternoon. Our next presenter this afternoon is Mr. Daniel Cunningham. Daniel is a horticulturist with Water University. His programs focus on sustainable landscaping and food production systems. Daniel specializes in Texas native plants and trees, vegetable gardening, edible landscaping, and rainwater harvesting. Daniel received a BS in environmental horticulture with a minor in natural resource management from Texas Tech University. While at Tech, he discovered a passion for water conserving landscapes while working towards an MS in horticulture, also at Texas Tech. His research focused on community development and implementation of integrated sustainable food production systems in arid areas. Please help me welcome Mr. Cunningham this afternoon.
Thank you very much, Justin. Or as my fiance says when she introduces me at parties, plants and stuff. Once again, I just, like the previous speakers, just want to thank you all so much for having me today. Spending some time at Texas Tech in West Texas in the Panhandle. It's an honor to come back. I left Dallas about 5 o'clock this morning. There's something just about watching the sun come up here over the plains. So thanks again for having me. There we go. Also, I just wanted to point out, if y'all are on social media, it's a great way to connect with me. I'd love to get your feedback on this presentation if you have any questions, or just to keep in contact and see what y'all have going on as well. Like Dustin said, I am coming here from the Dallas Research and Extension Center, where we focus on a lot of different issues facing urban agriculture, urban horticulture, whether that's through our research program that does a lot of stuff with drought-resistant turf grass and the breeding program there, different ways that we can save water in an urban area, but we also do a lot of things focusing on outreach through our extension program, but also through our research program on how we can be more efficient, more effective with our outreach on water education through our Water University program. The main focus there is through landscape and water management throughout the landscape. We do that with training through to homeowners, also professional trading, CEU type of programs. I also have some of our publications up here if that's anything that you may be interested in. Our deck of cards we use for homeowner outreach to help people select the right plants for their landscape, and then some other publications that go along with our 20-plus classes that we offer to those homeowners and professionals, each one of them targeting a different aspect of landscape water use, whether it's through food production or perhaps efficient turf grass production. We do efficient irrigation, teaching homeowner DIY practices, things like that. Just strictly water conservation as a topic is harder to get folks to come to, I think, as some of y'all in this room have probably figured out. And so we try and put the water conservation, stormwater spin on any aspect of landscape water use to draw more people in to those issues. I think last year we reached about 16,000 people and 340 classes between our three horticulturalists, Dottie Woodson, Patrick Dickinson, and myself, which may seem impressive to some, but when you consider that we live in an area with about 7.1 million people, it's just a drop in the bucket. So job security there, puns always intended. We also do outreach. We're blessed to have the opportunity to do some stuff with the local TV stations and newspapers there in the Metroplex, being active on social media, basically anything we can do to get the water conservation message out there, but also really our goal is to facilitate behavior change, to get people to turn the faucet off, to get people to turn their irrigation controllers off, especially in times when we're seeing sufficient rainfall. Like I said, blessed to be in Amarillo today. There are certain parts, like the previous speakers have mentioned, of Texas where we are blessed with significant rainfall. In the Metroplex, we've just seen some well-timed rain events to get us soil moisture for the growing season. But then there are other parts of Texas that certainly, like we are here in West Texas and the Panhandle, that don't see as much rainfall. And it's not necessarily a matter of if, but when we'll see a drought in that scenario. Sometimes we'll see flooding. Each of those rain events is ephemeral, and we don't know what year the year will look like. But hopefully we'll see some rainfall here in the Panhandle before too long. How much water do we have as a state? If we look at our existing water supplies from the Texas Water Development Board statistics, those are actually expected to decline in the next 50 years. About 15.2 million to 13.6 million acre feet, whether that is as a result of aging infrastructure, perhaps using up of groundwater resources. And so it is critical that we look at our water availability as a whole, those water supplies, and also how that relates to the development, the growing urban areas that we have, and how that affects water use. And so if we can imagine maybe a storm system coming in 200 years ago here in Amarillo, or maybe not too far from here, that rainfall, we'd see about 50% infiltrate into the soil where plants could use it. About 10% would be lost to surface water going to feed our creeks and local rivers. And then about 40% lost to evaporation to go reseed the clouds downstream. Now, if we plant a city, of course, we need parking lots and roads to feed that city. We've created plenty of impervious water surfaces, places where water does not infiltrate when it falls from the sky. So if we imagine those raindrops falling now, so many of those are going to hit the roofs of these buildings, those parking lots, those roadways, our driveways, our sidewalks, where we only see about 15% of that water infiltrate going into the soil as soil moisture where our plants can use it, and about 55% of that is lost to runoff, creating all different sorts of problems, not just in its sheer volume, but what it actually picks up when it goes downstream. So that runoff is moving with increased quantity, decreased quality, moving with greater speed, causing different types of issues. I know here we've seen record rainfalls in years past, and some folks that have been here a while said, well, it's never rained like that here before. And statistically that may be true, but also because there are less places for that rainfall to go, we see increased flooding issues, especially with those intense events. That water is picking up in municipal areas specifically, but also in rural areas, fertilizers, pesticides, different pathogens that may be present. Sedimentation or erosion, soil loss captured in that water, and then other toxic contaminants and debris, as well as thermal stress as it hits downstream. It's easy when we think about stormwater or water quality to pass the buck. If it's the folks that live in the more urban areas thinking, oh, it's the rural pollution, or it's the agriculture, whether it's farming or ranching. Or perhaps it's the farmers and the ranchers that see the pollution from the urban areas and pass the buck. But really, whether you live in an older community, some of the new developments here in the Panhandle, really we're all part of the same watershed, where if we think of the local watershed or larger watersheds across Texas, and if we could just practice better community stewardship collectively, if everyone makes better choices, then we all get the benefit from those choices. So a lot of times in the Metroplex, people refer to this hole inside of the curb as the sewer. Actually, it's the storm drain, and to remember that this is where water can go unabated, picking up those pollutants. And so if we protect every drop of water that is going to eventually head into those storm drains, then that will do a better job of not only protecting our surface water, but our environment as a whole. It's becoming increasingly more problematic as we see population growth that looks like this, exponential growth almost, 70% increase in population by 2070. If you thought traffic was bad now, anytime you went to Dallas, Austin, or Houston, I can't imagine what it's like. Even spending time in Lubbock not too long ago, the traffic has increased since my days there. And then if we look at this graph by the Texas Water Development Board, we see that line of population there growing in the pink, and then our water supplies declining. These two lines are growing in the opposite direction, which creates some challenges. Even with new development, new infrastructure for water resources, the demand is actually growing significantly, and the supply is decreasing significantly. And remember, it's not a matter of if, but when drought is going to hit your part of Texas, whether that's the Panhandle further south, or there's some folks from Central Texas here or in North Central Texas. Really, it does seem like some of our weather patterns are increasingly unpredictable. So if we build our landscapes, whether those are commercial, residential landscapes, rural landscapes, to build them as resilient as possible to these drought periods, then we're going to be better off when that next drought does come around the corner. We look back at the 2017 state water plan, something I would encourage y'all to read through. I've read through it 2 or 3 times now, which is fun Sunday afternoon reading. Conservation and reuse strategies, if we look at the past 15 years, have moved from 25, 34 to 45% of total water volume. So increasingly, it's imperative looking at conservation as a new source for water, and still some room for improvement there. A lot of that conservation is going to need to come to outdoor water use. If we look here at the Metroplex, one of the water-rich areas, depending on the year, but also a lot of demand on that water. If we look at the percentage of indoor to outdoor use, we're at about 41% there. So 41% of the water we're using by volume is going outside of the home. Surely some room for improvement. If we look at another city on that map, has about 40, about the same, which is both of those numbers are higher than the state average. Amarillo's right there with us. So certainly some room for improvement in terms of conservation. And let's turn back to indoor use. So indoor is making up in those two cities, Dallas and Amarillo, the largest part of the use. The thing with indoor conservation, however, is a lot of these technologies, if we look at the EPA WaterSense labeled fixtures, whether it's shower heads, toilets, all those ways we use water inside the home, typically when your commode breaks or something happens to it, you get a new one. Or if your shower head becomes corroded and it eventually fails, you get a new one. And so over the past 10, 15 years, each time that happens, that new technology that you're buying is more water efficient. Now, it's good to buy the most efficient product, surely, if you need one, but just through that time period, the engineering of those products have gotten good, where each one of those is more efficient than the next year. Well, where is more water? Where does more water come from? I know my mom specifically, but so many of my friends, when they want to talk, I don't know that they want to talk about water conservation, but when the topic does come up, people think about desalinization, and they think, oh, well, we're just going to take all the salt water out of the ocean or the aquifers that have salinity issues, and it's all going to be fine. And that may or may not be the case. Certainly, that's part of the solution. There's some issues in terms of the expense of building desalination plants, but also what are you doing with the hyper salinated water that's coming out of those? And then the maintenance up there could be expensive as well. Building new lakes is something that folks talk about. We're blessed to be getting a new lake here soon in the Metroplex, but that also is time consuming and uses a lot of financial resources. Whether it's recycled or reused water, certainly that's part of the picture, and in a way we're going to find new water supplies going forward, but also that is expensive and has its own issues in terms of the quality of that water. Aquifer storage and recovery. All these things we look at, each one of those has a price tag more expensive than the other, but conservation is the least expensive way to come up with those water resources. And one of the best, most effective ways to get to that conservation is through education and outreach. What is the cost of not implementing the plan? Surely those tolls would be great. If a large portion of the population faces a water shortage, that could cost billions in dollars of lost income, lost jobs, lost population growth, and then the taxes that are associated with those businesses. So that's really not an option. And then if we ever do see that drought of record, which is probably a matter of if but not when, and we run into that shortfall in terms of water supply, what would that scenario look like? And if we can make conservation efforts now, both us in our daily lives, but also in educating our friends and family to do that, then maybe we can avoid some of these potential problems. Another tool I wanted to introduce to y'all is the Texas State Water Plan has an online interactive tool, and you can actually go to your specific area, planning region A, which we're in right now, you can see, and you can look at specific population growth, which is kind of a fun tool, whether just to use for your own information or perhaps in education and outreach. You could also break it up to the water demands. So here we can look at existing supplies, demands, and needs, as well as those strategy supplies, the projects that the Water Development Board is funding. One thing just to note about this bar graph is when you look at whether it's 2020, 30, 40, 50 going forward, we see that pink line, the demand, is always slightly above that blue line, which would create pause and I think more incentive for conservation. This conservation is not just going to happen on the municipal side, even probably more so it will happen on ranches and farms around West Texas and Northwest Texas and all over the state, in fact. And surprisingly, a larger demand reduction will actually happen on that irrigation side. And I know there's some folks here locally studying that. With some great resources in terms of precision irrigation, also alternative cropping systems, and then technologies that would reduce the water demand on specific plant material, and there will be some other options there, but conservation in terms of irrigation is going to be a great part of that solution. In terms of the homeowner side of things, we partner up and do some trainings with the American Society of Landscape Architects. Each year they do a study asking homeowners what they want in their landscape. And surprisingly, and I think excitingly, a lot of homeowners are actually looking for resources, for elements in their landscape that would decrease the need for water in their landscape and also help benefit other ecosystem services tied into water. Overall, clients are looking for landscapes that are more environmentally sustainable. They want to reduce their water costs. They do this through rainwater harvesting and gray water harvesting, two alternative resources for water that will reduce our demand on municipal supply. Native and adapted plants, something near and dear to my heart. Pervious paving are basically just products in our hardscape, whether that is specifically like brick pavers or perhaps concrete that has been designed to infiltrate water. Anything in your landscape, whether it's a dry riverbed and an arroyo, that will help infiltrate water so the plants around it can take advantage of that moisture in the soil profile. Edible landscaping, another way to reduce our water demands or the demands associated with the production of food, growing and buying food locally, but then also growing some of it on your own property. We're seeing up to 35% of Americans now are growing some of their own food, the highest number we've seen in decades. Rain gardens, we'll touch on this, but basically just slowing sinking and spreading water through on-contour depressions in our landscape so we can take advantage of the water that's coming in the form of rainfall. drip and efficient irrigation. So these are technologies that have been around a while. They're the most efficient use of water. 90% of the water coming out of those water droplets in terms of drip irrigation is actually getting to the root zone where the plants need it, where we may see on a windy, sunny day up to 60% water loss through traditional irrigation methods, and then reduce lawn areas. Well, let's get back to talk a little bit about rainfall. So if we look at the Amarillo, Texas area, it's about 90.3 square miles. So if we think about a scenario where we're getting 20 inches of rainfall in a year, and maybe we'll get that this year, maybe we won't. But if we think about that average, sometimes more, sometimes less, and we get a 1-inch rainfall event comes over the city, that's about 1.5 billion gallons of water in a 1-inch rainfall event falling all over the city of Amarillo. And if we multiply that by about 20 inches of rainfall, does anybody here know what the consumption is in terms of municipal water in Amarillo? Yeah, somebody said 16 billion? That's exactly right, give or take. So if we have 16 billion gallons that we need to meet the demand of the municipal residents here, and we're getting about 31 billion gallons, we're getting twice as much in rainfall as we use through municipal water sources. Now, can we capture all that water in terms of harvesting in barrels or in the landscape? Certainly not, but it's something to think about, that if we're actually getting twice as much water as we need falling in an average rainfall year, it does make you think about how much of that could you capture on your property, whether that's through simple rainwater harvesting cisterns, with a first flush, putting clean water inside your tank in order to have clean water coming out that you could use throughout your landscape as an alternative water source. Or maybe in your commercial setting, if you have a barn or a business where you want to capture as much water as possible, maybe you're having trouble with your well, the quality of the water, you could actually, through more technology, you can filter that water to drinking water standards and bring that in there. We're doing this at the new research center in Dallas, where we'll flush the commodes with rainwater that we capture in a 30,000 gallon cistern. One tool that you may want to think about if this idea, rainwater harvesting, seems interesting to you. This is the Ag Science Building at Texas Tech. There's a calculator here at permadesign.com, and basically all you do is you type in the address of whatever building's on your property, and then you put a drop, a little pin on each corner of that roof. It measures the square foot of the roof. It uses weather data from NOAA to calculate the average rainfall per year in that area. And then once you have calculated that, or you hit it into the calculator, it calculates 60% of that water that you would have the potential to capture. So certainly we're not going to be able to capture all that water into tanks, but 60% is a good number to shoot for. And it is remarkable, in this specific setting, the water that they could capture in that tank would be enough to irrigate the entire grounds of that building for the entirety of that year. Which would significantly reduce the demands of water for irrigation. But a cistern only holds so much. We can hold water in cisterns and rain barrels like we have over here all throughout our landscape, but at some point that water is going to overflow, no matter what that rainfall event is. And so we can actually hold more water inside the landscape itself than we could ever hold in a cistern or a rain barrel. Whether this is to go and perhaps provide moisture to trees on our property, putting moisture by edible plants, by those native adapted plants that have benefit to wildlife and pollinators. We can do that in a few different ways. If we drive up and down the streets of Amarillo or a nearby city, typically we'll see a scenario like this in residential neighborhoods. We'll see maybe newly planted trees that have a ring around them in order to hold the water inside that ring. We also will see landscapes that are designed to shunt the water off when we do have rainfall events as quickly as possible. So every drop of that water is going to go away from the house. It's going to go down our sidewalks and driveways and then ultimately end up in the street. And then when we do want to water those trees, if you see here on the picture, how do we do that? We run our hose over there inside the tree ring, and then we turn the water on. Does that make any sense to anyone? So this water shunted off the property quickly as possible. That goes creating increased runoff problems. And then when we want to irrigate, then we're using that municipal water that has been cleaned up to drinking water standards and all the energy and time that takes. But imagine if we had landscapes that look more like this. Landscape that had rain gardens or depressions, even so slight, even if it was just an inch or 2 inches, that would slow down the water. And then once those rain gardens or depressions are filled up, where does the water go? Through the gravity and the adhesion of cohesion of water. Anytime it overflows from those areas, it would just go back to where it wants to go. It would go down the storm drains, down those sidewalks. So you would just be trapping some of that water, allowing it to infiltrate into your soil in urban areas, perhaps getting more infiltration than we would normally see in compacted or dry clay soils. We can also use that same technology in a process called curb cuts. So basically cutting curbs, holes inside of our curbs, that when that water is coming from your neighbor's house, I like to be greedy with my water. Every drop of water that falls on my property, I want to do my best to save that, keep it so my plants can take advantage of it. But our neighbors upstream, they're not doing that. So if some of their water is coming off their property, we could actually send it into those depressions in our, what people call our parkway or perhaps hell strips. And so we can encourage water to be slowly spread throughout those areas so the plants can take advantage of it there. So kind of holistically, if we do incorporate rainwater harvesting for its ability to store water in tanks and provide an extra source of water when we do reach a period where maybe we're not getting significant rainfall. And then if we're using curb cuts or rain gardens or those depressions, we could take advantage of that water, being greedy with those water drops, not letting them go down, causing stormwater problems downstream. Certain cities have used this type of technology to direct water towards trees. Those trees, as they grow and mature, can provide ecosystem services. This example is on the west side of a street that helps to shade the property. So it makes, certainly, I know in Lubbock and Dallas, when it's June, July, and August, nobody really wants to go on a walk, 4 or 5 o'clock in the afternoon because it's so hot. But when you have a street lined with trees, that may not be such a bad scenario. Rain gardens can be engineered simply through simple technologies, putting gravel and drainage pipe in the bottom, incorporating with compost, which works like a sponge with organic matter holding onto the water, but also allowing it to infiltrate. Planted with beautiful plants that work like pumps to help infiltrate that water, but also increase the amount of water that is taken up and sent down to reseed clouds downstream. We've looked at some studies on rain gardens there at AgriLife Dallas, and these rain events, you can see the blue line at the top. Most of these are about 1-inch rainfall events. In a 1-inch rainfall event, we can capture 40 to 45, almost 50% of the water that ended up in that rain garden from a whole parking lot stayed in that rain garden. So maybe 55% of that water that would have normally gone down the storm drain and caused flooding problems and pollutants in that runoff stayed there on the property and was infiltrated. We also have the potential to pick up any of those pathogens, the different pollutants in terms of fertilizers that would normally be going to our surface water resources. So whether those are nitrogen or phosphorus or perhaps salts that would normally be in that water, we can bioaccumulate those through the rain garden in the soil or the plant material itself. Another option you may want to look at is reducing turf areas. Like I mentioned earlier, certainly turf can be a value in our landscape. We do a lot of breeding research and we recommend turf in the right spot. But turf can, especially in the panhandle, require more water demands than a lot of our native and adapted plant materials. So if we reduce the turf areas to about a third, that's plenty to throw a football or have your kids or your grandkids play on. But if we increase the areas with more native and adapted plant material, mulched and irrigated properly, that actually will decrease the total volume of water that you're needing to use for supplemental irrigation on your property. The other thing that we want to look at is pervious hardscapes or permeable areas that can infiltrate that water when we do get rain. If you create arroyos or patios that can infiltrate water, then the plants around there can take advantage of that. We want to slow the water, sink it into the landscape, and pervious hardscapes can be a part of that solution. And then if we move into the summer months, perhaps we are going to need to supplementally irrigate even those turf grass areas that are efficient or the native and adapted plant materials. And that does make a large component depending on the year that we have in terms of water use, whether your irrigation system is your irrigation controller or perhaps your system is dragging a hose around. It's important to remember that irrigation should only supplement the lack of rainfall. If we just got a rain event and your irrigation system is set up to go off on your watering days twice a week, then you're not getting efficient use of that water and your water bill is going to be higher. So really, we should only be running our irrigation system, like I said, if that's an automated system, or if it's you watering your vegetable garden or some pots or containers on your property, that should only be done if we're not getting rainfall. And I would take it a step further on my property, as I'm sure a lot of y'all do in conservation, is I'm looking at the weatherman. I watch all 3 channels, seeing which one I can trust the best, thinking, okay, is it going to rain in the next 2 days, and how much water how far can my plants go without extra irrigation? I would much rather take Mother Nature's water than use my municipal water, A, because I'm into water conservation, but B, just because I'm cheap. So as professionals engaged in making decisions about how water is used, it's important to consciously seek and involve fundamental attitudes to better serve the community. So whether this is your co-workers or these are your neighbors, anytime we can promote the right practices, as much as I would like it with AgriLife Research and Extension, our information doesn't always get to the public as efficient as we would like. And so most people are just listening to the local expert, whether that's a master gardener or the person on the block that has the greenest yard. And so if you can be evangelical with your water conservation message, whether that's at work or at home, then more people will hear about it. They'll see that their plants don't need as much water as they once thought, and you can have healthy, vibrant landscapes. We do that by a few ways. Water only when required. So like we said, if it's raining, we probably don't need to irrigate. Water deeply to promote healthy roots. If we're watering frequently, then the moisture is just staying at the top of the soil, and there's no need for the root zone or plants to grow deeper roots. If we water deeply but more infrequently, it encourages deeper root growth, and so plants can take advantage of the water lower in the profile. Earlier, a gentleman talked about cycle and soak irrigation, breaking up your irrigation in order to sink that water down in the soil profile, using 2 to 4 inches of mulch and shrub areas to hold the water in the soil, but also it allows more water to infiltrate, designing systems for efficiency, installing per state and local specifications, and then to water without creating runoff. The concrete is growing fast enough around here. We don't need to water it. And so I kind of just wanted to leave you with 3 questions. What is the story of your place? If that's the Panhandle, or if you come somewhere a little bit further from here. And how does water tie into that story? What is your relationship to your place? So were you from here? Did you grow up here? Did you move here? What is that relationship? And then what is your role in the story? Whether that's your role as an educator, your role as somebody who's in the business of conservation, or your role just as a community member that cares about leaving a legacy of stewardship to your kids, your grandkids, your great-grandkids. That's all I